This is a related rate problem. So since most students don't like implicit differentiation, I've taught myself how to do this problem without using implicit differentiation. So here's a good example. So water is being pumped into a vertical cylinder of radius 5 meters and height 20 meters at a rate of 3 cubic meters per minute. How fast is the water level rising when the cylinder is half full? Now, always, when you do these kinds of word problems, draw a picture because you're going to have to use the picture to build relationships, okay? So we got a cylinder, just a typical Quaker oatmeal box cylinder. We know the radius all the way down from top to bottom is 5 meters. We know the height, total height from top to bottom is 20 meters. We have water level somewhere in here at a height h from the bottom. Just some random height. Don't put it smack in the middle. Don't put it clear at the top. Just some random height of water there. Now that's the picture, but we have this rate here because we're going to relate rates together. That's why we call them related rates. So we have a rate that's given to us of 3 cubic meters per minute. Now cubic meters is a measure of volume. Cubic meters per minute is a measure of the change in volume with respect to time. Volume in meters cubed and time in minutes. And it says it's 3. So that's what's given to me. I mean, they just hand that to me on a platter. Then they also say, okay, what is it that we want? So I write down what I'm given, I draw a picture of what I'm given, and then I think about, okay, what is it that the question is asking me? The question says, how fast is the water level rising? And then they want to know exactly when the cylinder is half full, so that's got to have something to do with 10 meters, but we'll get to that in a minute. How fast is the water level rising? So what we want, the water level I have measured as h, so I want to know dH dt, which is meters per minute. Somebody asks you, how fast were you going? You always say feet per second, miles per hour. That's how I know it's going to be a height per unit of time, meters per minute. This is what we want to find. Now this 10 meters is some level h that we're going to use right at the very end. Now, the rates that we relate, so here's the job where we relate rates together. I think about, well, this is what I want, dH dt, and I'm given this rate, dV dt. Now I'm going to think about what rate can I multiply dV dt by, put in this box, multiply dV dt by, to end up with dH dt. And it's kind of something you have to think about for a second. So I want dH dt to end up here, so that means that if I put dV here, the dV's will cancel, so to speak, and then if I put the numerator here as dH, then these guys disappear and I'm left with dH dt. Now that's really not technically what's happening. This is an example of the chain rule, but it's a good way to relate rates together so that we get what we want based on what we have. Notice that's what we're given, and then this is what we have to also relate together, H and V somehow. So the thing that's in the box over there is what we need to relate separately. Need to relate. Boy, if I can spell relate, that'd help. Relate V and H together based on this problem somehow. Now I know I'm given a cylinder. I know the volume of the cylinder has a base of height in it. So, I mean, it's based on the height. So the volume of a cylinder is pi r squared, which is the area of the base, times the height. Now, since we have a cylinder, no matter where I am, no matter what my water level is, no matter what h is, my radius is always going to be 5. And that's what makes this a little more straightforward problem. So r is always 5 because it's a cylinder. So that means that V is equal to pi times 5 squared h V is equal to, I'll probably have to push this up a little bit. V is equal to 25 pi h. Now what I need over here is dh dv. What I can find over here, I can find dv dh. So the derivative of v with respect to h is actually quite straightforward too. Derivative of h is 1, so that's 25 pi is the derivative of v with respect to h. But I want dh dv. Well, if dv dh is 25 pi, then dh dv is 1 over 25 pi. So putting this all together back up here, I want dh dt, dv dt is 3, so I want dh dt, dv dt was given to me as 3, and I've calculated in a separate relationship over here, dh dv as 1 over 25 pi. So if I simplify that, I get 3 over 25 pi, and if I put that in my calculator, I get my change in h with respect to t, my change in height, how fast the water level is rising, is equal to 0.0382, and the unit of measure. Height is measured in meters, time is measured in minutes, so it's meters per minute.